Hi guys, my name is Terry. In this video, I'm going to go through the SPM trial paper 2022 for the subject Additional Mathematics. And this is MRSM paper for paper 1. Okay, let's get started with question number 1. This is from Form 4, Chapter 6, Linear Law. Here we have a diagram that shows part of the curve y squared equals b over 2x plus q such that p and q are constant. So you're supposed to find the value of p and q. Okay, so if you look at the diagram here, maybe I move this up a little bit. Now, if you look at the diagram, the graph passes through 2 points. The first point is minus 11, 4. Second point is minus 5, 2. So what we need to do is substitute inside both coordinates separately to form two equations so we can solve for p and q. Now, the first part, I'm going to sub in minus 11 and 4, meaning your y is now 4, I square it, equals p over 2. Your x is now negative 11, u plus q. Now, to simplify this equation, we can actually multiply everybody by 2. Now, we know that when you multiply by 2, this will be negative 11p. Let me write p first. And then q times 2 is 2q. 4 squared is 16. 16 times 2, 32. So that will be my first equation. Then I substitute the second equation, second coordinate, negative 5 and 2, meaning my y value is 2, I square it. My x value is negative 5, and you plus with q. Now, what I need to do is the same thing, multiply by 2, give you a fraction. So you get negative 5p plus 2q. We know 2 squared is 4, 4 times 2. This will give us 8, and that will be equation number 2. So I need to solve these two equations simultaneously. So let's take equation 1. You subtract with equation 2. So when you subtract, your minus 11 minus minus 5, that is minus 11 plus 5, gives us negative 6, right? The 2q and 2q will cancel each other out. As for 32, when you minus 8, you're left with 24. So when you bring it over, 24 divide negative 6, p is just minus 4. Now let's take this and substitute inside any equation. Here, I think I'll just sub inside equation number 2. My p value is now negative 4 plus 2q is 8. Minus 5 minus 4 is 20, positive 20. Bring it over. 8 minus 20 is negative 12. Q is negative 6. Negative 12 divided by 2, answer is negative 6. Okay, next. Once you got the p and q value, we're supposed to sketch the linear graph of y squared against x squared. So we know p and q already, so we can take this and sub inside this original function. Your y squared is now, your p is negative 4, you divide by 2, x, your q is negative 6, sub inside. Basically, your y squared is now minus 2x minus 6. So remember, your y squared is your big Y. This is your gradient. This is your x. And this is your c. Yep. So I need to plot y squared versus x now. So when you plot y squared versus x, you will get a straight line. However, you notice that your gradient is negative. And your y-intercept is also negative. So this graph is a bit unique because it's not... Normally, we draw the graph upwards. This one is going downwards from left to right. Not only that, it will cut the y-axis on at the bottom part. The y-intercept is now negative 6. You can picture it this way. Your y is now minus 2x minus 6. Your gradient is negative 2. Your y-intercept is minus 6. So we put the minus 6 here, right? This is your y squared. This is your x. This is your origin. Yep, that will do. Now, you don't really need to show or find your x-intercept. It's not really required. Make sure that you draw a graph with a negative gradient and your y-intercept must be negative 6. Question number 2, this is from Form 4, Chapter 2, Quadratic Function. You're given that 2 alpha and 2 beta are the roots of this quadratic equation. Find the value of m if alpha plus beta is -2. So I hope you know by now a general form of a quadratic equation is ax squared plus bx plus c. Let me write over here. If you have ax squared plus bx plus c equals to 0, and the roots are alpha and beta, your sum of root SOR is alpha plus beta equals minus b over a. Product of root POR is alpha times beta and is c over a. Now, if you look at this equation, my roots are now 2 alpha, 2 beta. So when I calculate my SOR, right, my 2 alpha plus 2 beta must be negative b over a. Now you can look at your equation here. My a is actually 1. A is your coefficient of x squared. My b is now m. And my c is now -3. So as I put negative b over a, my b is m. My a is 1. I can find the value of m. Now, you're given alpha plus beta is -2. But to use this information, we must first factorize the 2. Take out the 2, you're left with alpha plus beta. The result is -m. Take your alpha plus beta, sub in with -2 from here. And this is -m. So we know -m is -4. Your m is just 4. Yeah, quite easy, right? Now, next, I need to form a quadratic equation with the roots of alpha and beta. So remember, to form a quadratic equation, we need to know our SOR and our POR. Yeah, let me write down here, x squared minus SOR x plus POR equals to 0. Now, you already know your SOR. Your SOR is alpha plus beta. It is given here as -2. I just need to find what's my POR. Now, I need to go back to the first equation here, the equation that we were given earlier, right? We need to find out our POR. Now, we know the roots are 2 alpha times 2 alpha, 2 beta now. Yeah, 2 alpha times 2 beta, because that's POR, product of root. Take these two, multiply together. The result is c over a. My c is now -3. My a is 1. So for alpha beta is -3. Alpha beta is -3 over 4. All right, we're not done yet. We know our SOR, we know our POR now. Okay, now sub inside and find our equation. Okay, so the equation or the quadratic equation will be x squared minus my alpha plus beta is -2. So let's put -2 inside x. My POR is -3 over 4. Let it be equal 0. So normally when we write in general form ax squared plus bx plus c like this, right? We normally do not have answer or coefficient in the form of fraction. So if you have fraction like 4, we will multiply everybody by 4. So you get 4x squared plus 8x minus 3. The result is 0. Okay, this question number 3 is from Form 4, Chapter 1, Function. So diagram shows the graph of y equals fx and x equals to gy. You're supposed to determine which graph represent a function and state your reason. Now remember, what is definition of function? A function is a relation for which every object has one image, right? Or should I say every x value has only one y value. So we can do what we call a vertical line test. We can just draw a vertical line here across anywhere on the graph. And you notice that as I draw a vertical line around here, I have one x value. As I move across, I have one y value here. So this is what we call a one-to-one relation. One x mapped onto one y, right? So this is a function because every x value has exactly one y value. Now for the second graph, when I draw a vertical line here, now my line is not very straight, sorry. Draw a vertical line here. I have one x value here. But when I move across, I have two different y values, y1 and y2, right? So this is actually what we call a one-to-many. This is one-to-many relation. This is a one-to-one relation. Now, not to say that only one-to-one is a function. Many-to-one is also a function. as long as every x value has only one y value, or every object has exactly one image. So in this case, to answer part A, as this is only 1 mark, we say the answer is, okay, which function? Answer is fx. Which graph represent? Okay, when they say graph, you better write y equals fx. Okay, so this is the answer. And state your reason. Why? We say every object has exactly one image. Now you can even say every x value has exactly one y value. Also can, right? Okay. So that's it, 1 mark. You don't have to explain why gx is not a function. If the question gives 2 marks and say which one is a function, give a reason. Which one is not a function, give a reason. Then you have to do that. Yeah, since this is only 1 mark, you can just mention fx is a function. Yeah, y equals fx is a function. And the reason is every object has one image. Okay, part B. State the domain of the range, and the function notation. Okay, if you look at this graph here, this is a straight line graph. Okay, a straight line graph. You notice in this case, your horizontal x value represent your domain. Now your domain actually starts from 0 to 5. So we can say B Roman 1, your domain will be x. Okay, well, we don't have to write in the exact notation. I know some of you, because if you remember, if it's a discrete, we normally write 1, 2, 3. We put this braces, or I call it the sexy bracket, right? We do that, okay? But for range, right, normally it's not required to do that, because if you want to write it in a proper notation, we say x dot dot x is an element of real number and x is between 0 to 5. Well, this is the most appropriate way of writing, but it's actually not necessary. Yeah, so you don't have to write like this. We just write in the form of inequality will do, because this is what we call a continuous function, not a discrete function. A discrete function, it takes a single value like 1, 2, 3, 4. Then we can use this, the braces, the set notation. I call it braces. Okay, but in this case, it's not necessary. We just write in inequality form. Now, as for the range represents your y value. As you can see, your y value starts from -4, it goes all the way up to 6. So my range will be -4. You can write fx, you can write y, doesn't matter, it's the same thing, up to 6. Yeah, -4 to 6. And as for function notation, okay, this is a bit interesting. Since it's a straight line, we can apply y equals mx plus c method. Yeah, or you can use the coordinate geometry y minus y1, mx minus x1. But since I already have my y-intercept, right, I just had to find out my gradient. Now look at this coordinate here. This is actually 5, 6. This y-intercept is actually 0, -4. So we can use 6 minus -4, 5 minus 0, that will give us 2, right? My gradient is 2. And my y-intercept is -4. So when you use y equals mx plus c, your fx is 2x minus 4. That's all. So that's your function notation. It's easier to do it this way rather than using substitution. I know some people say I use fx equals ax plus b. Since it's a linear function, I sub 1 by 1. I sub x with 0, y with -4. Then I got b equals to -4. Then I know fx equals to ax minus 4. I sub another coordinate. Let's say I sub 2, 0. When your fx, when your x is 2, since it passes through 2, right? Your y is 0. So a times 2 minus 4 equals 0. 2a is 2. 2a is 4. A is 2. Therefore, my fx equals 2x minus 4. Yes, you can do that, right? But for me, it's a bit longer, right? If you can use y equals mx plus c, why not? Since it's a simple linear function or a straight line graph. Okay, question number 4a. So you're given gx, you're given gfx, you're finding f3. Okay, so this is the case when you're given a function and the composite function, and you're finding the function inside. We call it function inside. Now, let me just do a sketch for you. It looks like this. If you have, okay, perhaps I just draw the sketch here, then I do the working on the other side. So this is just for you to understand. When we say gfx, it means fx happens first, followed by g. So this composite function is gf, right? So you're given gfx, you're given gx. That means you're finding what? You're finding the function inside, you're finding fx. So there are many ways to do it. Actually, we can use substitution, we can use comparison, we can use inverse, okay? But I think most people would use the substitution method because that is the first method that you learn in school, because this part of the chapter, composite function, it comes before inverse, right? So let's just go straight to substitution, yeah? So we start by letting the function inside becomes y. Now, when I say function inside, means the function that occurs first. Function that happens first, which is fx. You let it be y. So we write gy. Notice that this is gfx. Don't write fx, write y. And this is now 2 over x minus 1. So what we have here is function gx. I'm given gx. But what I have on my solution here is gy. So basically, I replace my x with y. Instead of writing 5 plus 2x over 3, I write 5 plus 2y over 3. The result is 2 over x minus 1. Now, remember, I'm finding fx. I'm finding f3, actually. But before I find f3, let's find fx, which is y. Now, multiply the 3 over 5 plus 2y is now 6 over x minus 3, right? Now, I'm going to bring this 5 to the right. So I will have 2y equals 6 over x minus 8. And since I want to find y, I have to divide everybody by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. My y is my fx, and my fx is 3 over x minus 4. But I'm not done yet. I'm not finding fx. I'm finding f3. To find f3, we will have to substitute 3 inside. So it's 3 over 3 minus 4, which is 1 minus 4. Answer is -3. Okay, it's not too difficult, right? All right, this is only the first part, part A. So we have the second part, part B, over here. So the next part, part B here, you're given the inverse function H inverse. And H inverse is 4x minus 7. You're supposed to find Hx. Okay, now I'd like to clarify, because most of the time in school, you use the method that is you let whatever that you're finding, which is, in this case, Hx. You let whatever you're given. Sorry, there is a difference. Given the textbook method, or should I say the new textbook? Yeah, the current textbook that you use. We let whatever that you're given equals to y. The super old textbook, or the old textbook, yeah, this is the one I like, yeah, because old is gold, young is junk. So we let whatever that you are finding, or whatever you wanted, equals to y. So that is the difference. Because when you let whatever you're given equals y, you're finding x. You're making x as a subject. If you let whatever you wanted to find as y, you are finding y. You're making y as a subject. So I don't want to show you too many methods, because if you're more familiar with the old textbook, but the new textbook method, go ahead, okay? Just use that method. It's just x and y, just the other way around. So here I'm going to let whatever that I'm finding, which is hx, I let it be y. Then I will interchange h inverse y, I let it be x. Okay, I hope you understand this. If you let hx, this is hx, it maps x onto y. When I go backwards, h inverse y, it will map your y back to x. So basically your x and y interchange. Your object and image will now switch position. And I know my h inverse. My h inverse is now 4x minus 7. H inverse x is 4x minus 7. H inverse y will be 4y minus 7. So what are we finding? We're finding hx, right? Which is y. So I need to make y as a subject. So this is x plus 7. And I divide by 4. So I get my y, which is hx, as x plus 7 over 4. Right? This is B Roman 1. Fairly simple, right? Okay. Now, like I said, if you prefer to use the first method, right? You let hx equals to h inverse x equals to y. You can, you just make x as a subject. You will still get the same final answer. Okay, Roman 2. Now, express P in terms of K, given that H inverse H of K plus 5 is now HP. H inverse H of K plus 5 is now HP. Okay, so first thing you need to know, what is the meaning of H inverse H? All right, H inverse H. Okay, maybe I just write here. Now, when we say H inverse H, we are referring to the function H happens first, right? So let's say I start from X. I go through function H, all right? And let's say I get Y. Then I follow this on with H inverse. So it looks like this, H inverse H, let's say X, meaning HX happens first, followed by H inverse. So I move forward, right? Let's say I arrive at Y. Then starting from Y, I move backwards. I get back my X. So you notice when you have H inverse HX, you are actually getting the same thing as where you started. You're getting back X, right? It doesn't matter whether it's like, for example, G inverse G5, your answer will be 5. In fact, if you reverse the position, you say, okay, what if I do F inverse 7? Well, I will still get 7, yeah, because F inverse means I go backwards, I go forward, I end up at the same place where I started. So when you have H inverse here, it will just cancel each other off. You would just be left with K plus 5, right? And as for HP, since I really know this function HX, I'm just replacing X with P. So I got P plus 7 over 4. And I'm finding P as a subject. Let's multiply over 4K plus 20 is now P plus 7. Bring the 7 to the left. P is 4K plus 13. There you go. You got P in terms of K. Okay, moving on to question number 5. This is from the chapter 4, Form 4, Indices, Surds, and Logarithm. So here you're given that log base 10a is less than 0. State the range of values of a. Okay, so I hope you understand, right, that in the in a universe of number, okay, the smallest number you can ever get, okay, let's say this is 0. The largest number you can ever get, okay, let's not talk about this decillion and so on, or centillion, right? 10, this is million, right? Billion, trillion, yeah, centillion, and so on. Okay, let's not talk about that. Let's talk about infinity, the largest number ever, infinity. The smallest number ever you can get is negative infinity. So if you try to take the logarithm of this number, okay, so let's say these are your index, okay, index, okay. Let's say your base in this case is 10. So what is 10 power negative infinity? Well, you get 0. Now, to understand this, we know that power negative means 1 over 10 power infinity. And 10 power infinity is just infinity. And 1 over infinity is 0. I hope I don't have to explain much about this. 1 over like 10 is 0.1. 1 over 1,000 is 0.001. 1 over infinity, a very large number. So many 0 is 0.000000001. So it's a very small number. We can just say 0. Okay. All right. So now, how about this? How about 10 power 0? 10 power 0 is 1. And how about 10 power infinity? 10 power infinity is still infinity. Okay, so when you write in logarithm form, although it's mathematically not right to write negative infinity or 10 power infinity in logarithm form. But if I change from logarithm form, from index form to logarithm form, we know that a power x is y. So when you write in logarithm form, we write log base a y is now x. So here, the first one, log, what's your base? 10. What is your number? 0. The result, negative infinity. Second one, log, what's your base? 10. What's your number? 1. What's your power? 0. The third one, log base 10 infinity equals infinity. Now, why do I show you this? To help you understand that when your number, you see, log base 10a is less than 0. Less than 0 simply means this number is, if you want to write this down, is between 0 and negative infinity, right? We are talking about this and this, right? That means your number A is your number, yeah? So your number must be here, this one, 0 and 1. If your number is between 0 and 1, your logarithm value is always less than 0, right? So here, conclusion, your A must be between 0 and 1. Well, we can always use a calculator to test it, okay? We use a number, okay? Let's say a number between 0 and 1, say 0.1, that is between 0 and 1. Your logarithm value is going to be less than 0. Or even, we don't even have to use decimal, can use fraction, 2 over 3. This is a number between 0 and 1. Can you see it's negative? It's always less than 0. But the moment you take a number more than 1, let's say 1.2, it's going to be positive, right? And of course, you cannot put a value that's less than 0. You try to put a number less than 0. For example, negative 1. You get math error because there's no such number. Yeah, we cannot take logarithm of a number less than 0. Now, let alone take the logarithm of a number that is 0, right? Math error. Okay. So I hope I answer your question on this, right? It's only 1 mark. You just have to write this. Yeah, you just have to write this line, but it's just that some students don't understand why the logic behind it. So that's why I explain from here. All right. Second one, given that A is now 7 power x, B is 7 power y, you're supposed to simplify this 49 power x plus y plus 7 power x minus y in terms of A and B. Okay, so this is on indices. This is answer for part A, answer for part B. I prefer to do it over here. So let's first break this up, okay? We break up the 49. Now, 49, maybe we can write 7 power 2 first. There is an x plus y. This is a plus 7 power x minus y. Okay, I'll do slowly, one by one. All right. Now, next, I can actually switch, multiply over if you want. Okay, 7 power 2x and 7 power y, 2y, sorry, 2y. This is 7 power x minus y. Okay, so now we know that a power m power n is a power m times n. Basically, you multiply the two numbers, just like what I did here. I multiply the two inside one by one. Now, next, we also know in logarithm, in indices, when you add the power, when you break it up, it becomes a multiplication. So this is 7 power 2x times 7 power 2y. As for subtraction, a power m minus n, when you minus the power, we divide the number. So this is 7 power x divide 7 power y. Now, before you substitute, because we need 7 power x, right? Maybe I can switch the position of 2 and x. I put the 2 outside. Now, remember, this a power m power n, we can put mn together. We can even put n inside, m outside. Just switch their position. This will be 7 power y with the 2. And this is 7 power x, 7 power y. Now, why do I do that? Because I want to replace my 7 power x with a, 7 power b with y. So this will be a square, b square. This is a over b. Yeah, a square, b square, a over b. Okay, question number 6. Yeah, I like this question because a lot of times if you do the SPM past year question, you really come across exponential, and exponential is in your new KSSM syllabus, the E here. So yeah, this is one of the example of question involving E, exponential function. So here the population of bacteria A grows according to this function. A power n is 2, AN is 200 EN. The population of bacteria B is BN equals to 20 E power n plus 1. N is number of days. So the first part A, find the total population of bacteria A on the second day. On the second day, your n is 2. All right, so bacteria A, we use A. You can write 2 here, doesn't matter. Yeah, is 200 E power 2. Okay, we can use our calculator. This will be 200 shift ln 2. My answer is 1478. Ignore the decimal. Don't write the decimal. Say 1477.8. They want half a bacteria, not the full bacteria. We don't count. Yep. It's 1478. Yep, that would do. Okay, next. Part B. After how many days the total population of both bacteria will exceed 800,000? Now, the keyword is total population. That means your A plus B must exceed 800,000. Now, the function for A is 200. This is E power n. For B is 20 E power n plus 1. And this is greater than 800,000. Now, I don't like the number in front. I think I can just divide by 20. Let's simplify this. When I divide 20, I get 10 En. When I divide by 20, I get En plus 1. And 80 divided by 20 is 40. So there's is 4. So I put a 4 here, 0, 0, 0, 0. You're not sure you can use a calculator. Just basically cancel 1, 0. Take 8 divided by 2, you get 4. Now, the thing is I need to solve for n. But the problem is I have En here. And I got another En with a plus 1 that is linked together, that's put together. So I need to separate them. I need to separate this out. Okay, so to do so, we use the law of indices. That is, when I give you a power m plus n, and remember we did a question like this just now, we break it up, a power m times a power n. So I'm breaking this up, e power 1. Now remember, e is just a constant. E power 1 is this, a shift ln 1. It is 2.71828. It's exponential, right? Now, I'm finding n, but n is a power for e. Let us factorize the e power n. Let me take out the e power n from here, take out e power n from here. So what we have here is 10 plus e. E power 1, we can write this as just e, is greater than 40,000. So let's divide this. Use your calculator. 40,000 divide 10 plus shift ln 1. Just put 1 with the, and this will give us 3145. Yeah, 3145. Okay. So, okay, let's write 3145. Now, from here to the next step, I'm going to change from exponential to logarithm form. We know that e power x equals y. When you change to logarithm form, we say x is log base ey, or the short form is ln y. So in this case, m is greater than ln of 3145. Okay, use our calculator. Ln of 3145, you can just type in the answer, yeah, 8.054 or ln 3145. There you go, 8.054. Therefore, what do I take? N is 9. Greater than 8.054, we take n equals 9. So after 9 days, right, the total population of bacteria will exceed 800,000. Okay, question number 7. So according to part A, according to a study of an express delivery system service, 2% of packages mailed through a company do not arrive at their destination within the specified time. So state the type of random variable involved and give your justification. So here's the thing, they ask you for the type of random variable. There are only two types of random variable, discrete random variable versus continuous random variable. So in this case, we are talking about the number of packages, yeah, mailed through a company, right? So it should be a discrete random variable, yeah. The number of packages is discrete. It's not measurable, it's countable, yeah. Continuous are measurable, discrete random variables are countable. So why? How do you give justification? We say the number of packages, yeah, they are countable. Or should I say the number of packages is countable? Yeah, the number, yeah. Okay. Now, next, part B. Let me move it up. In a jewelry store, 2 out of 7 customers bought jewelry on a certain day. So if 10 customers from the store are selected at random on that day, find the probability that exactly 4 of them bought jewelry. So here's the thing, the 2 out of 7, it represents your probability. Yeah, probability that randomly customer bought jewelry is 2 over 7. Now, the 10 customer is a sample. Out of 10 people randomly chosen, you want exactly 4. So this is a binomial. You can write in this notation. This is B, this is N, this is P. But if you don't write like this, it's fine. Yeah, this is just a notation. Okay, so you want exactly 4 of them. Yeah, exactly 4 out of 10. So we say 10 choose 4, P power 4, Q power 6. Remember, the formula for binomial is given as Px equals to R and CR P power R Q power N minus R, right? So let's use our calculator, all right? Now, there are 2 ways to use the calculator. One, of course, the standard way. We take 10, choose 4, multiply by 2 over 7, close bracket, power 4, and then 5 over 7. Yeah, remember, P and Q, they are given by this. P plus Q is always 1. If your P is 2 over 7, your Q is 1 minus 2 over 7, which is 5 over 7. P stands for probability of success. Q stands for probability of failure, right? And remember, in binomial, there are only 2 possibilities, either success or failure, right? Either they buy the jewelry or they didn't, right? So this one is power 6. My answer is 0.1859. 1859. Okay, of course, if you have this calculator, the class width calculator, life will be a lot easier. You press mode. You go to number 7 for distribution. You go to 4 for binomial. All right. You go to 2 for variable. And your x value is 4. Your n value is 10. Your p, probably a success, is 2 over 7. There you go. My p is 0.1859. So you have less things to type in your calculator because you just have to key in your n, your p, and your x value. Okay. Now, one thing I need to know, be careful with this, because part A, we are talking about 4 people actually bought. Yeah. Part B, we're talking about at most 2 did not buy. So now your probability will change, right? So your x value is now different, as in you can change the p value and say p is 5 or 7 because x represent people who do not buy, whereas the first part, x represent the number of people who actually bought, right? So you want at most 2. At most 2 means maximum 2. It can be 0, it can be 1, it can be 2. Now here again, I have many ways to show you. Now you can choose to do the slow way. Slow way means we take out of 10, I choose none, 0. P is 5 over 7, power 0. Q is now 2 over 7, power 10. Now remember, 10 minus 0 is 10. Then you add 10 C1, 5 over 7 power 1, 2 over 7 power 9, and 10C2, 5 over 7 power 2, 2 over 7 power 8. Okay, I'm going to use this calculator first. Then I'm going to show you how to use a summation function in your calculator. You press Shift, lock here. There's a sum formula. Then Shift C. This is X. We use a general formula alpha X. Multiply. Your P value is now 5 over 7. Close bracket power alpha X. Then you multiply 2 over 7, close bracket power, then minus alpha X. Okay, now let's press equals. Oh, sorry, I forgot to add in my X value. My X value starts from 0 to 2. Press equals. I got a very small number. You can press Shift ENG just press this button, Shift ENG twice to shift the decimal point. Is 0.000114. Very small value, 0.000114. All right. Now, of course, you can use this calculator as well. This calculator is such a fantastic calculator, save time. You press mode, you go to save, you go to 7 for distribution. Now, take the replay button, press it down. You go to number 1, binomial CD. CD means cumulative density. The word cumulative means you add up, right? So you press 2 for variable. When we say cumulative value of 2 means 0, 1, 2, all right? But remember, you need to use your P value as 5 over 7, right? So there you go. I'm getting the same answer, right? Shift ENG twice. See that? 0.00. Okay, I think I messed up. I put 000. Supposed to be 00, right? 00,1114. Sorry, 00,1114. There you go. That's your final answer. Okay, whether you use this calculator or this calculator, the black one is the same. Okay, question number 8. This is from permutation and combination. The first part A, is actually a combination question. So a school mathematics quiz competition team consists of 15 participants. So these participants are to be chosen from 8 boys and 10 girls. Calculate the number of different ways the team can be formed if at least 8 girls are chosen. So first of all, we have 8 boys and 10 girls, and you have total 15 participants. So you want at least 8 girls. Okay, so up to you. You want to put boys first, girls later, doesn't matter. Maybe I put 10 girls here and 8 boys here. We want at least 8 girls. Okay, so these are the cases, if you like to call it. Yeah, there are 3 cases I have to consider. Case number 1, I can choose 8 girls, right? At least 8 girls means I can choose 8 girls. Case number 2, I choose 9 girls. Case number 3, I choose all 10 girls. Now I can't choose more than that because maximum number of girls I have is 10. Okay, as for boys, remember your total number of participants should be 15. So if I choose 8 girls, I must choose 7 boys. If I choose 9 girls, I must choose 6 boys. So your total is 15. If I choose 10 girls, I must choose 5 boys. Yeah, so that my total is 15. Now, I always like to work it out this way first before I calculate or write my answer. So it works like this. So let's start with the girls. 10 girls, choose any 8, right? At the same time, 8 boys, I choose 7. Now, remember, this is multiplier because it is n. N means it occurs simultaneously. I have to choose the boys and the girls at the same time. I can't choose the boy without the girls, right? Then this is a plus. Plus means or. Or means it can be this combination or this case, or the second case, or the third case. Now you see case by case is or, right? Then I have to use plus sign. Then 10 choose 9, 8 choose 6. If I choose 9 girls, I must choose 6 boys. Another or, 10 I choose all 10, and 8 I choose 5. Okay, so what we need to do is to add them up, all right? Now, even that I have a calculator method, you can type one by one, but it's kind of slow. I like to use the formula here, right? The summation. Let's start with 10. Shift C. You see, one thing that changes is the number of girls. Your girls can begin with 8, 9, or 10. So I put alpha X, okay? Then for boys, 8, shift C, I put a bracket because your total must be 15, right? So if I choose X girls, boys should be 15 minus X, right? Now I'm going to move this down and I'm going to put from minimum 8 girls to maximum 10 girls. And my answer is, oops, I must have typed in wrongly somewhere. All right, 8C 15 minus X. I think I forgot to close the bracket here. There you go. 696. Now you can use the manual way. If you count, you type in the manual way, you get the same answer. It's just that sometimes when you type the manual way, right, it's a bit long and we tend to maybe type wrongly sometimes, right? So it's a bit long. So we use this function. In a way, it's easier and faster. All right. So the first part is combination. Second part is permutation. Okay, so I like the permutation type of question because in the past few years, SPM question has been quite ridiculously difficult. All right, so this one's pretty standard. I like this question because it also involved the new KSSM syllabus, the circular arrangement, right? Okay, so here we have 7 pearls and 6 beads, different colors to be arranged using different ways. All the pearls are arranged in a circle to make a bracelet, as an example. Yeah. So, okay, they show you here. While only 4 beads are arranged on a hair clip, as shown in this example. So we have 6 beads here, right? We want to arrange 4. Whereas we have 7 pearls, we arrange all, but we arrange in a circle. Okay, so I hope you know by now for circular arrangement. Okay, first of all, they say are the number of different ways to arrange the pearls on the bracelet is equal to the number of different ways to arrange the beads on the hair clip. Verify answer. Okay, for circular arrangement, I hope you know by now, if you don't arrange in the circle, if I arrange them this way, right? Okay, like 7 items in a row, the number of ways is just 7 factorial. But the moment you join this together, right, like this, and then you connect the last one with the first one, what happens is you have 1, 2, 3, 4, 5, 6, 7. And we can actually rotate them at 7 different positions. For example, let me just say this one is the red one. So I can put the red one in the first position here. Yeah. And I can put the second position. I mean, I can rotate it at different position. Third, fourth, fifth, sixth, seventh. So there are 7 different ways we can actually rotate them, and they actually have the same thing. For example, let's say the red one here. Let's say I have the green one here. The green one is actually next to the red one, right, on the right. And then let's say my yellow one is on the last part. When I connect the yellow next to the red, right, and I rotate them at 7 different positions, the green is always on the left-hand side of the red. The yellow is always on the right-hand side of the red. So we're actually having 7 different same position. It's just that we see it from different angle, right? So always remember, you got to divide by 7. All right. Now, another thing about bracelet is because we can actually flip them over. Okay, sorry, because my camera is blocking. So I'm going to draw another one for you. So this is like a mirror image. My red one is over here, right? When I flip it over, the green one is now on the left here. The yellow one is now on the right. And of course, you have the rest here. The rest, I don't want to show you everything. Yeah, just want to make this quick. When you flip over, yeah, a bracelet like this, right? You notice they're actually the same arrangement, right? Although one is going in the clockwise direction, when you flip over, it actually goes in the anti-clockwise direction, but they're actually the same arrangement. So in this case, you must always multiply by half or divide by 2. So only for things that you can flip, like bracelet, necklace, keychain, and so on. Like for people sitting in the table, no, you cannot flip them, right? It's not possible. You try to flip them, they'll be like upside down like this, all right? So it's not possible to flip people, all right? It's possible to flip bracelet. That's why you got to times half, okay? All right, so when you times half, let's calculate. This will be 7 factorial. Let me clear this. 7 factorial, oops, 7 first. You divide by 7. You can write 6 factorial, and then you times 1/2. So this will give us 360. Okay, well, just so you know, another way of thinking is this. Let's say you have yellow, you have red one, I put it here. I fix the position of the red. 1, 2, 3, 4, 5, 6. I got 6 others. So when you fix the position of the red, you have only one way, but I still have to put the rest of the pearl. There are 6 other ways to put the rest of the pearl. That's 6, 5, 4, 3, 2, 1. So that's 6 factorial. Then you multiply by half because you can flip them, go to half the number of arrangement, because clockwise, anti-clockwise, they're actually the same. You are getting the same thing, 360. Yeah, so you can take thing 7 factorial divided by 7, or you can think 1 times 6 factorial. They're the same, but just make sure you multiply by half. Okay, so this is the clockwise, anti-clockwise arrangement, all this for the pearl. Now let's talk about beads. Now this is easier because why? This is the pearl, the pearls, this is the beads, right? The beads we have 6, and we want to arrange 4 only on the hair clip. So it's 6B4, right? Out of 6, arrange 4. 6 shift B4, it will give us 360. Okay, to answer this question, they say, are the number of the arrangement for pearls the same as the beads? Answer is just yes. Yeah, it's only 2 marks. 1 mark for this, 1 mark for this, and they just say yes. Okay. Okay, moving on to question number 9. So here we have a diagram that shows a straight line PQ, right? And unit vector in the direction of PQ is given as this. You're supposed to find the value of n and express OQ in the form of column vector. Okay, now I hope you know by now, when we say PQ is actually OQ minus OP, but if you don't want to do this, you find this is confusing, you can say P to O, O to Q. P to O, O to Q. You can do that. Huh? And P to O is negative OP, and then you plus with OQ. Let's put OQ in front, OP at the back. Now, my OQ, if you look at this, is if I write in column vector, is n10, and my OP is minus 3, 8. So when you put it together, you get n plus 3 and 2. All right. Now, actually, it's not necessary to do this because the question wants you to find n. They gave us the unit vector already. Now, as we know, unit vector of r is given by vector r. Let's say vector r is xi plus yj. Divide by its magnitude, x squared plus y squared. All right. Now you can see that this is ki plus 2j. That means that the unit vector this, maybe you can write this as k2. Instead of dividing with 29, we write 1/2 square root 29. Now we can see your k is actually the same as n plus 3. And your 2, can you see, is the same as the 2 here, right? So we know the magnitude of this vector is square root 29. So perhaps we can say, we can find, you can find k first, then you find n, or we can straight away say that your n plus 3 square, all right, plus 2 square, which is the magnitude of PQ, is now square root 29. So let us square both sides. My n plus 3 square plus 4 is now 29. 29 minus 4 is 25. Square root of 25 is plus minus 5. But we don't have to be plus minus 5 because we can see n is more than 0. N is on the right-hand side of the y-axis, right? So we take n equals to 5 minus 3, n is just 2. Okay. First part done. Second part with that, express OQ in the form of column vector. your column vector OQ already have it here actually. It's very simple because we already know your n is 2. So your OQ is just 2, 10. Right? Pretty easy, right? Okay, so this is vector in Cartesian coordinate. The next one is vector in, we call it vector geometry. Now, you're given a quadrilateral. You're supposed to prove that LM is parallel to KN. Okay, actually, this question shouldn't say prove that. You shouldn't say prove because lambda is a variable, right? Whether they're parallel or not, it depends on the value of lambda. Your lambda must be a specific value such that they're parallel, right? Okay, anyway, we are given to all the vectors. If I want to go from k to n, k to n is going downwards, right? So maybe I would start off by saying kn is kl plus lm plus mn. My kl is 3a. My lm is a plus b. My mn is, since you're going opposite direction as to this, right? So it's negative lambda 5a plus b. Let us expand this. This is 4a plus b minus 5 lambda a. And multiply the lambda inside 1 by 1. So minus lambda b. Now we're going to put together your a and a, right? So it's going to look like this. 4 minus 5 lambda a. Put together your b and b. So you have 1 minus lambda b. So that is your vector kn. All right, now to prove that Lm is parallel to kn, you can say Lm is a multiple of kn, or you can do the other way around, right? Maybe I should put kn first because I like kn first because I don't have to multiply another multiple inside. So normally we say when two vectors are parallel, vector A parallel to B, A is a multiple of B, lambda B. But since we already use lambda, I don't want to use lambda. Use another symbol. Let's say mu. You can use other letter like K, M, N, up to you. But since I already have K, L, M, N here, let's use the Greek letter mu. Mu K, L, M. Okay. Now, we know our Kn. Our Kn is 4 minus 5 lambda A. Then you add with 1 minus lambda B. My Lm, we already know as A plus B. Let us expand this mu A plus mu B. So by comparison, let's compare one by one because we need to find lambda and mu. The coefficient A is this two, right? So we can say by comparing A, 4 minus 5 lambda is mu. First equation. Then we compare vector B. The number in front is 1 minus lambda is now mu. So 1 minus lambda is now mu, equation number 2. So we know they are equal. So we can say 1 equals 2. 4 minus 5 lambda is 1 minus lambda. Bring over. 4 minus 1 is 3. 5 bring over. This will be 5 minus 1 is 4 lambda. Your lambda is 3 over 4. Now, as you sub inside, let's say equation 2, my lambda is 3 over 4. My mu is 1 over 4. So in this case, like I said, the question perhaps shouldn't say prove that they're parallel. They should say express, given that they are parallel, express Kn in terms of Lm, or the other way around, because they are not exactly parallel unless your lambda has a specific value, which is 3 over 4. If your lambda is 3 over 4, then they will be parallel, and your Kn is now a quarter of Lm. Yeah, therefore, yes, Kn is parallel to Lm. Remember, two vectors are parallel. The first vector is a multiple of the second vector. Okay, now for those who write Lm equals to lambda, or in this case, mu Kn also can, but I think your mu will be 4, but the other way around. All right. Okay, question number 10. This is from Form 5, Chapter 6, Trigonometric Function. So here we're given sine alpha is negative 3 over 5, tangent beta is 2, alpha beta, they are angle in the same quadrant. Now remember ASDC here, all science teacher crazy. Only science teacher, not math teacher. So sine is negative in quadrant 3 or 4. Tangent is positive in quadrant 1 or 3. So in this case, we have to take quadrant 3 because quadrant 3 sine negative, tangent is positive, right? So it fulfills the two conditions that we want. We want the sine to be negative 3 over 5 and tangent beta to be 2. So when you draw this, right, please draw in this orientation. This is your x-axis, this is your y-axis. So your sine alpha is here, quadrant 3. Move down towards the x-axis. This is your reference angle. The big angle is your general angle. Alpha is your general angle, right? Your reference angle is the small angle over here. Since it's in quadrant 3, sine is opposite, which is 3. Put a negative here because this is negative. Below the x-axis, your length is negative, and your hypotenuse is 5. Your adjacent is 4. Put a negative. We know it's 4 because we use what? 3, 4, 5. Yeah, Pythagoras. Now, for your beta, again, I draw in quadrant number 3 like this. Your beta, it's positive, but tangent, remember, is opposite over adjacent. If you get 2, 2 means 2 over 1. So that means this is 2, this is 1. But remember to put the negative in front of 2 and in front of 1 because it's on the left-hand side and below the x-axis, both the length, both the coordinate-wise, it should be negative. As for your hypotenuse, we can use minus 1 square plus minus 2 square square root. Doesn't matter whether it's positive or negative. When you simplify, your hypotenuse is always positive. 1 square, negative 1 square is 1, 2 square is 4, 1 plus 4 gives us 5. So now I know my triangle. I've drawn my triangle, okay? I'm supposed to find the value of m given that cos alpha minus beta is this. Okay, so let's expand this. Cos alpha minus beta. Remember the addition formula for cos. Yeah? This formula is given in exam. So cos A minus B is cos A, cos B plus sine A, sine B. Remember, cos is opposite. If it's a minus, it'll be a plus here. If it's a plus, then it'll be a minus here. Yeah, the other way around. So let's expand. Cos alpha, cos beta, plus sine alpha, sine beta. Okay, my cos alpha, if I read from here, is negative. Yeah, cos is adjacent, adjacent over hypotenuse. So it's negative 4 over 5. Yeah, negative 4 over 5. Let's write this down. And cos beta, if I read from here, is negative 1 over 5. Sine alpha, if I read from here, is opposite. Is my opposite over hypotenuse. In this case, is negative 3 over 5. Sine beta is also opposite out over hypo, minus 2 over 5. Okay, we can put this together. This is actually 4 plus 6. You can see minus 4 times minus 1 is 4. This is 6. 4 plus 6 is 10 over 5 5. We can simplify this to 2 over 5. Now, however, the answer is written in this form. You can see in this form. That means the question actually rationalizes the denominator. It wants you to rationalize the denominator. So we multiply top and bottom by 5. So this is 2 5 over 5. And we can tell the value of m is just 2. Okay. That is just part A. We still got part B to go. Now, for part B, we have addition formula for tangent. So first of all, we need to expand this formula. This is tangent theta minus 60 equals 1. Now, we know that tangent A minus B, when you expand, is tangent A minus tangent B over 1 plus tangent A, tangent B. Again, now this formula is given If it's a minus, it will be minus. The bottom part is a plus. If it's a plus, this will be a plus. The bottom part will be minus the other way around. So let's expand this. This is tangent theta minus tangent 60. Divide 1 plus tangent theta tangent 60. The result equals -1. Sorry, it's not 1, it's -1, right? Okay, you're supposed to find the value of k in surd form. That means you're finding tangent theta, right? K is your tangent theta. Now, tangent 60 we can find out because we can use a calculator. Nowadays, it's so easy. With this calculator, tangent 60 is just surd 3, right? If you don't have this calculator, normally what we have to do is we draw a triangle here, isosceles triangle, equilateral triangle. And we know this is 60, this is 2, ratio 1, 1, this is 90. Your opposite is 2 square minus 1 square, square root, which is square root of 3. All right? So we can actually find what is tangent 60, right? Surd 3 over 1. So this is tangent theta. This is surd 3. 1 plus tangent theta and a surd 3. Then the result is -1. Okay, my job is to solve for tangent theta. So let's multiply over. This is tangent theta minus surd 3. This is -1 minus surd 3 tangent theta. Okay, if you find the tangent theta is a bit annoying, but perhaps we can just substitute k inside. So after all, you're finding k, right? So maybe I sub inside here, k minus surd 3 equals -1 minus surd 3k. Yeah. Bring this over. Bring this over. So you have surd 3k plus 1. Oops. Surd 3k plus 1. U plus surd 3k plus, should I say plus k equals surd 3 minus 1. Let's factorize the k. Surd 3 plus 1 equals surd 3 minus 1. So when you divide it, we get surd 3 minus 1 over surd 3 plus 1. Remember, you need to rationalize the denominator to find the value of k, right? We multiply top and bottom with surd 3 plus surd 3 minus 1. Yeah, you need to multiply with its conjugate. The conjugate of surd 3 plus 1 is surd 3 minus 1. So when you expand this, guys, this is actually surd 3 minus 1 square. When you expand it, it's a square, which is 3, 2ab minus 2 surd 3, -1 square is 1, divide by surd 3, v square is 3, minus 1 square is -1. Okay, I better continue here. It's easier to see if I write over here. Now I'm left with 4. 3 plus 1 is 4 minus 2 surd 3 over 2. When you divide by 2, 4 divided by 2 is 2. 2 divided by 2 is 1. So your k is 2 minus surd 3. All right. Okay, question number 11. This is from the chapter Differentiation, from 5 chapter 2. So here we have a normal to a curve is parallel to this straight line. Yeah. We're supposed to find the value of a and b. So let's say this straight line, right? We know, say this curve looks like this. This is the straight line. The normal to this is a tangent to a curve. Oops, I'm missing a point. This is a tangent to a curve at a point. The point is 1, 5. This is the normal to the curve. Yeah. And this is your tangent. This is your normal. And the normal is parallel to this straight line. This straight line is x plus y minus 8 equals 0. Okay, so here we have two unknowns that we have to find. The unknowns are a and b. So the first thing is we already know that the curve passes through this point. So what we can do is we can sub in the coordinate. Yeah, the coordinate will be 1, 5. As I sub in 1, 5, my y is now 5. My x is now 1, right? So 1 squared is still 1. So your a plus b is now 5. So this is my first equation. Now the second equation, we know that this line is parallel to normals. But first we need to find out the gradient of this line. Yeah. So what we can do is we make y as a subject, we bring everything over. So your y is minus x plus 8. So the gradient of this line is now -1. Therefore, your gradient of normal is also -1. Remember, gradient of normal times gradient of tangent, the result is -1. My gradient of tangent is now -1. Now I need to find my gradient of tangent, right? So that when you differentiate this function, dy dx represent the gradient of tangent. So I'm going to differentiate this now, dy dx, bring the power down, we get 2ax. Remember, when you differentiate ax power 2, I'll bring the power down, copy x, reduce the power by 1. Now, in the event that x is below, right, for me, I always use this. I always teach my student to use this method. It's faster. You put a negative in front, copy a times n, copy x, increase the power by 1. Now, I know a lot of people bring x up, differentiate, then bring it back down. For me, that is a bit slow. So I'm going to use the fast method here. Put a negative here. I copy b times 1. This is 1. B times 1 is b. I copy x. I increase the power by 1, 2. And let us substitute your coordinate. Your x value is now 1 when your dy dx is -1. Okay, let me continue over here. Now, when I sub inside, my dy dx is -1. My x is 1. My b here, I put 1 inside. 1 squared is still 1. So my 2a minus b is now -1. Right. Okay, sorry, I made a mistake. My tangent is 1 here, wrote wrongly. -1 times -1 is +1. Sorry, your dy dx is 1. Right. So 2a minus b is now 1. Okay, I've got two equations now, right? Equation 1, a plus b is 5. Equation 2, 2a minus b is 1. Now let's take equation 1, add the equation 2. So 2a plus 1a is 3a. B minus b disappear. No more b. 5 plus 1 is 6. A is 2. Then you sub inside equation 1. Your a is 2. Your b is now, bring over, b is 3. All right. Okay. Well, actually, there is a mistake in the numbering. So this question is supposed to be 11a. And the second part supposed to be, yeah. Okay, sorry. This is question 11, right? It's just one question, very short question, actually, 4 marks. Sorry. Okay, question number 12. This is from the chapter differentiation as well. The first part is involving rate of change. Okay, so here variable f and g, they are related by this equation. 1/f plus 1/g equals to 1/15. Given that g increases at a rate of 1.2 cm per second, find the rate of change of f. Yeah, when g is 20. Now, here's the problem. If you are finding rate of change of f, yeah, and you're given rate of change of g. So for me, I always do it this way. The rate that you're given is dg dt. This is given 1.2. The rate that you wanted is df dt, rate of change of f. Now, to link them, we have to use the chain rule. We write df dt. All right, break up your df and dt. Put the dg here because I know my dg dt. I need to find df dg. So to find df dg, I have to differentiate f with respect to g. Now the problem is to differentiate this at form 5 level. We need to make f as a subject. F is not written as a subject yet. So we need to rearrange this equation such that we bring the 1/g to the right. This is 1/15 minus 1/g. Group them together, cross multiply. This is g minus 15 over 15g. Okay, and from here, we need to make f as a subject. I invert it. F equals 15g over G minus 15, right? Make F as a subject. Now, only then we differentiate. Now, here, remember, this is involving the quotient rule. For example, even y equals u over v, when you differentiate dy dx, we write vu prime minus uv prime over v squared. My v is my denominator. U is my numerator. So we copy your v, differentiate 15g, your u, which is 15, minus copy your u, 15g, differentiate your v. And remember, differentiate 1g, you get 1. Differentiate 15, you get 0. So this is just 1. Divide by your v, 15, g minus 15 squared. Now, you can actually sub in straight away g with 20, but I thought maybe we just simplify this. It's not too difficult to simplify. 15g, 15 times 15 is 225, minus 15g over g minus 15 square. When you cancel your 15g, you're left with this, right? G minus 15 with a square. Okay, I'm not done yet. I just got my df dg. But I need to sub in here. And we want to find your df dg when your g is 20. So when your g is 20, your df dg is now negative 225 divide 20 minus 15 squared. Okay, use our calculator. All right, negative 225 divide 20 minus 15 is 5. Then you square it. Answer is negative 9. Okay, but we are not done yet. This is negative 9. We are finding df dt. So we know our df dg, which is negative 9. We know our dg dt, which is 1.2. So let's take negative 9 times 1.2. Answer is negative 10.8. Yeah, negative 10.8. There you go. That's your rate. Now, you can write the unit. The unit is going to be cm per second. But if you don't write, it's okay. So if you're not sure, please don't write the unit because there's no marks given for the unit. Right. All right. This is the first part. First part is rate of change. Second part is small change and approximation. So I like this question. It's a bit interesting, a bit different. Your diagram shows the curve y equals 1 minus x squared. Find the first derivative of y respect to x. Okay, don't panic about this term. First derivative, what is first derivative? dy dx. Second derivative is d2y dx squared. So that means we just have to differentiate this dy dx. So when I differentiate 1, I get 0. Differentiate negative x squared, I got minus 2x. There you go. That's your first derivative. Okay, then they say calculate the approximate value of q in terms of p and k. Okay, so here's the thing you need to know. There's a difference between small change and approximate value. So when we say small change in y, we're talking about delta y. Delta y over delta x, as we know, is approximately dy dx. Now, this is true when your delta x is small. Now, picture this. If originally the line, okay, maybe my line I draw with blue color, the gradient of tangent at P is here. Okay, my line is not very, very straight. Let me draw one more time. And let's use a thicker line. A thicker line will make it look a lot better. Okay, sorry, it's still very ugly. Yeah, there you go. Okay, so it looks something like this, right? Sorry if it's not very nice looking, not very straight, okay? Now, the gradient of tangent at P, we can find by substituting your x value, which is P inside. That's your dy dx. Then you can find your delta y. Delta y means small change in y. To find the approximate value of y, we need to find the initial value of y plus delta y. So this is your delta x actually. This is your delta y. When your delta x is small, the gradient dy dx is approximately the same as gradient of delta y over delta x, right? Which is this formula here. All right. But once your X actually change, your Y will also change. Initially, when your X is at P, your Y initial is here. Y1 or Y initial is here. When your X increase by delta X, your Y will actually, in this case, reduce by delta Y. It reduces. Then you just add the reduction here, right? So this is the formula to find the approximate value of Y. Okay. So I need to now sub X with P. So the problem with this question is that they put unknown. Most people are familiar with number. If I put number inside, yeah, you can understand. Unknown is just a bit annoying because you just have to leave your answer in terms of P. So dy dx is your gradient at X equals to P. In this case is negative 2P. Now, next, I want to find my delta Y. I really know my delta X, right? By the way, if you're not sure, what is your delta X? When we change from P to P plus K, what is your increment? Your final value is P plus K. Your initial value is P. Your increment is just K. So when you take delta Y divide delta X, which is K, the result is your dy dx over here, which is minus 2P. Everybody, I'm substituting minus 2P from here. I multiply over my delta Y is negative 2PK. That is your delta Y, small change in Y. Okay, to find the approximate change, I must first find my initial value of Y. All right, initially, your X is P. What is your Y? Your Y is 1 minus, sub inside your Y here, P squared. This is your initial value of Y. We can just call it Y1. So my approximate value of Y is my Q. I'm using this formula now. Approximate value of Y is my Q. Right? Q is the final value. Is your initial value 1 minus P squared plus your delta Y. Guys, your delta Y is this. So I need to add in minus 2PK. All right. So we can just leave our answer in this form: 1 minus P squared minus 2PK. You want to put a minus 2PK in the middle, minus P squared at the back also can. No problem. So this will be your approximate value of Q in terms of P and K. Okay, let's move on to question number 13. It's a very interesting question, okay? I must say it's a bit challenging, okay? So here, table 1 shows the monthly rental schedule. House, you can see here, the rental period is for 2 years, 2021 January to December 22. This is 2 years. And 2023 to January to December 2024 is another 2 years. January 25th, 2025 to January 26, another 2 years, and 2027 January to 2028 December is another 2 years. So every 2 years, you will increase the monthly rental. Okay, so now they say that house owner will increase the monthly rental on regular basis every 2 years. All right, determine whether the monthly rental form an arithmetic or geometric progression. Verify your answer with calculation. Okay, you can see this is your T1, this is your T2, this is your T3, this is your T4. To determine whether it's arithmetic or not, yep, we take T2 minus T1. In this case, 710 minus 660. We can see the difference is 50. Then we take T3 minus T2. 760 minus 710, you also get 50. And if I take T4 minus T3, which is 810 minus 760, I still get 50. So increase at a constant rate. Every 2 years increase by 50 ringgit. So now, how do you explain the answer? Since T2 minus T1 gives us T3 minus T2 equals T4 minus T3. Therefore, this is an arithmetic progression. It's an arithmetic progression. Your common difference will be 50. Okay. Now, part B. When will the monthly rental exceed 1,350 for the first time? Okay, so we want to find what is your N. So we know that every 2 years you increase by 50 ringgit. So your A is 660. Your D is 50. your Tn will be greater than 1350. So in this case, let's use the formula A. Remember, for arithmetic, Tn is A plus n minus 1d, this formula here. So my n minus 1d here is more than 1350. Okay, now instead of expanding this, right, I like to bring the 660 over. I'm taking 1350 minus 660. Whatever I get, I divide by 50, then I plus 1. My n is 14.8. So again, let me say again, is 1350 minus 660 over 50 plus 1. N is more than 14.8, right? So n should be 15. Okay, getting 15 is not a problem. The challenge is, which year is it? Yeah. Okay, so you need to find when it will exceed 1350. Okay, so let me just show you over here. Now, here's the thing you need to know. If the first part in the beginning of 2021, it is T1. Beginning of 2023 is T2. Beginning of 2025 is T3. Correct? So every 2 years, you increase by 50. The question is, if I want T15, what year is that? So you notice you increase by, to find out the year, right? We start from 2021, right? If your n equals to 2, you actually plus 2. If your n equals to, to get to T2, you need to plus 2 once. To get to T3, you plus 2 twice, right? To get to T15, you must plus 2 14 times. See that? Get the idea or not? Yeah, you must plus 2 14 times. So it's basically 21 plus 28. I hope you don't need to use a calculator. 21 plus 28, 14 times 2, that will give us 49. So the year is 2049. I hope you get the idea. To go to T2, you plus 2 once. To get to T3, you plus 2 twice, right? To get to T15, you plus 2 14 times to get to 15. 1 plus 14 gives us 15. So this part is a bit confusing for some people. All right, C. This is the most annoying part. All right, calculate the total rental paid to the house owner from 2028 to 2056. So here's the problem. 2028 is still here. It's still in the T4 if you like. Yeah, this is your T1, T2, T3. It's still in T4. You're still paying 810, but you're only paying 810 for 1 year because 2027 you start at this rental rate. 2028 also you're paying 810, but you're only paying 810 for 1 year. Then in 2029, starting from January, you pay another rate, right? A different rate. So here's the thing. You need to break it up into 2 parts. The first part is how much you have to pay for 2028. Okay, 2028, you're paying the amount that you're paying, right? You can, I write this as amount. The amount you're paying is 810 for 1 month times 12 months. Okay, let's count. 810 times 12 months. So you're paying 9720. 9720. Okay. But from 2029 to 2056, we need to find how many period there are there. How many 2 years period you have. All right. So to find out that how many 2 years period, we take 2056 minus 2028 over 2. Now, here's the thing. You might think it's 2056 minus 2029, but we cannot minus 29 because we got plus 1. We have to count that 2029, that year itself, right? So if you want to write 2029, you must add 1 to it, right? So I'm just going to write 2028, right? So if you take this, right, 2056, you minus 2028, you divide by 2. We know that they are 14 2 years period. Yeah, they are 14 2 years period. That means you increase you start from here 810, you increase it 14 times. Okay, you need to increase the fees, the rental 14 times. Okay, so what is your A now? Well, my A is now 860, not 850, not 810, because from January 2029 onwards, you have to plus 50. Is 860. Okay. Now, by the way, maybe I shouldn't call it A first. Because I find it's a bit hard to calculate this. If you count monthly, then you have to times 12 months in the year, then you have times 2 years. So it's actually easier to make a progression based on the total amount collected for that 2 years period. So to make the total amount collected for 2 years period, we know this 860. 860 is how much you pay for 1 month. 1 year, there are 12 months. For that 2 years period, you times 2. It's easier to count if you put it that way. Yeah? So it's 860 times 12 times 2. That gives us 20,640. 20,640. This is the total amount collected from January 2029 to December 2030. That period, you collected this amount. Okay, but we're going to increase this to 14 for 14 period of this. So we are finding S14 now. Use n over 2, 2a, 20640 plus n minus 1, which is 13d. Okay, by the way, what is your d? Okay, your d is every 2 years period, you increase the monthly rental by 50. But in 1 year, there are 12 months, you times 12. Right? So, and then you go to times 2 years. So that will be 1,200. So every 2 years period, you increase the rental in total by 1,200. Okay. By the way, for those who are not sure, SN formula, let me write down here, is given by n over 2, 2a plus n minus 1d. I like to use this formula directly. Okay, let's find out what is this value. 14 over 2 bracket 2a, my a is 20640, n minus 1 is 13, d is 1200. Guys, I got the 398160. Yeah, 398160, but we're not done yet. We need to add this amount. Wow, this is long. This amount to this amount to find your total. Okay, right? To find your total. So my total amount will be 9720 plus 398160. Okay, let's count. 9720 plus 398160. What's your answer? 407,880. 407,880. All right. Okay, question number 14. This is a question from the chapter integration from 5, chapter 3. So here, diagram 7 shows the curve y equals x cubed and x equals y cubed and x equals y squared that at point O and point B. So find coordinate point B. Okay, so the first part we can actually solve them simultaneously. X equals y cubed, equation 1. X equals to y squared, equation 2. Basically, equation 1 is equal to equation 2. So your y cubed is now y squared. Bring your y squared over. Factorize your y squared. Now, obviously, your y cannot be 0 because 0 is here. I want to find coordinate point B. Your y must be 1. When you sub inside equation, any equation 1 or 2, your x is also 1. Therefore, your coordinate point B is just 1, 1. Okay. First part, no problem, right? Second part, we are finding the area of shaded region. Okay, you can see both region, right? They are bounded by x in terms of y. So for me, I would just integrate respect to y rather than respect to x. Remember, respect to x is y dx. That means you start from the curve, you move down towards the x-axis. Respect to y is x dy. You start from the curve, you move over to the y-axis. Now, I will use this because your x is already written as a subject. So the thing is, the bigger one, as you can see, is the one on the right-hand side. The x equals y squared is bigger. If you move towards the y-axis, the x equals y cubed is smaller. And we already know the y coordinate is 1, right? So to find the area of shaded region, what we can do is we can take integration my x, the first one is y squared dy from 0 to 1. Yeah, the lower limit is 0, upper limit is 1. You minus 0 to 1 y cubed dy. Okay, actually we can group them together because they have the same limit. So when I integrate y squared, I get y cubed over 3. Yeah, remember, increase the power by 1, divide by the increased power. Same here, y4 over 4, 0 to 1. Now, let us substitute 1 inside. I get 1 over 3 minus 1 over 4. If I put 0, the whole thing becomes 0. So this will give us 1 over 12. Yeah. Okay, unit square. Now, for integration, you can always use a calculator. This one, integrate. But instead of y, we write x. You can put alpha x squared minus alpha x cubed, right? And then lower limit 0, upper limit is 1. So there you go, 1 over 12. I know my answer is correct. Okay, part B. Calculate the volume generated in terms of pi when the region bounded by the curve x equals to y squared, straight line y equals minus x plus 2, and y-axis is revolved 360 degrees about the y-axis. Okay, the annoying part about this question is that they didn't actually draw for you the straight line y equals minus x plus 2. Okay, so let me just sketch for you. Where is this minus x plus 2? We know this line must have a gradient of -1 and your y-intercept is 2. Now, the thing is, I need to check whether it passed through point B or not, right? So we know for this line minus x plus 2, when your x is 1, your y is minus 1 plus 2, your y is also 1. So we know it passes through point B. And we know from y equals mx plus c, your y-intercept c is 2. So we can do a sketch like this. The graph will cut here at 2. This is at 1, 1, right? So this one is 1 over here. Now, the question says, volume when the curve bounded by the curve x equals y squared. X equals y squared is this line. All right. And then straight line x minus x plus 2 and the y-axis. So we are talking about this shape here. Now I'm going to take this and rotate 360 degrees about the y-axis. So the top part is a cone. The second part, bottom part, we have to use integration. Now, you don't have to draw this, but drawing helps to understand that it's basically a cone like this. You add the volume generated from integration. Okay, now this cone, you notice that the radius is 1 and the height is also 1. So your volume will be 1 over 3 pi r square h. Yeah, your r is 1, your h is 1. Now, for the integration below here, we need to integrate pi x squared dy. Remember, when you rotate about y-axis, is x squared dy. Lower limit 0, upper limit 1. All right. So 0, 1. My x is now y squared. I need to square it further for the dy. Okay, so this is going to give us 1 over 3 pi. This one, let's take out the pi. Let us square it first. You get y power 4 dy. Okay, I'm not done yet. When I integrate, I will get y power 5 over 5. Lower limit 0, upper limit 1. Okay, I'm going to sub 1 inside. Okay, so this is 1 over 5 minus 0. So it's basically 1 over 3 plus 1 over 5, which gives us 8 over 15 pi. Yeah. All right. If you're not sure, you can use a calculator, guys. You can integrate like this. I've shown you many times, right? You can put a pi if you want, or you can just put x square, which is x power 4. Lower limit 0, upper limit 1. Yeah. So take this. 1 over 5, just add 1 over 3. You should get 8 over 15. Just add a pi at the back. Okay, last question. This is from the chapter Coordinate Geometry. This question is rather annoying. Yeah. Diagram shows the rectangular wall surface PQSV. Anas wanted to mark point A so that the wall fan could be installed at a position accurately. So the switch of the fan is located at point R. He has made measurement using two straight string PT and QU. State the coordinate point A. Okay, now be careful that the question says using R as origin. So maybe I will just write or draw this line here. Okay, my line may not be very straight. Sorry, this is my line here. This is my origin, x-axis. This is my y-axis. Okay, you want to find coordinate point A. You can see here that we actually move from here to here. This is 4, this is 1, this is 4, 1, 2. The length from here to here should be 1. So you're moving 3 units to the left. This is minus 3, all right? And then you're moving up by 0.5. This is 0.5 here. You can see this is 0.5, right? 3 units to the left, 0.5 unit up. All right. So the coordinate of point A is minus 3, 0.5. Okay. All right. Now, next, find the distance of VU and of UT so that two straight string intersect at point A. State the ratio of VU, UT. Okay, so here's the thing. We need to form the equation. Yeah, we need to form the equation. By the way, at this line here, maybe I write the coordinate. The coordinate here is 1. U and T, they are both at the line y equals 1. This is y equals 1, a horizontal line. All right. But I need to form the equation. Maybe we write the coordinate for all this. We can see for P, right? I'm going 4 units to the left. I'm going, this is 3 minus 1. This is 1, right? This is 2. So we go down minus 4 minus 2. Okay, you know coordinate point A already. Your A is minus 3, 0.5. For Q, right, you can see is 2 units below. So this is 0 minus 2. Okay, I need to form equation of B, what do you call that? PT and equation of U cube. Okay, let's start with PT. Okay, so to form the equation of PT, right? We know PT passes through A, right? So we got to use this coordinate. My gradient will be, let me take y2, 0.5 minus y1, -2. x2 is -3, right? Minus -4. Okay, so this is 2.5 over 1 is 5 over 2, right? Okay, so this is the gradient of PT. Now, PT also passes through point A. You can use point A, you can use point P, up to you. We do y minus y1. Let's say I use point P, it's easier. Y minus y1, gradient 5 over 2, x minus x1, your y plus 2. Okay, maybe I times 2 over. I don't like the fraction. All right. 2y plus 4 equals 5x plus 20. 2y equals 5x plus 16. Okay, remember, to find the coordinate of, you're finding distance what do you call that? VU and UT. Before you find distance VU, UT, you need to find coordinate point U, right? U lies on the line y equals 1. So we put y equals 1, sub inside, find your x value. Okay, bring the 16 over. 2 minus 16 is minus 14. x is minus 14 over 5, or you can say 14 over 5, yep, is 2.8. Yeah, you can write negative 2.8. Okay, so my x is negative 2.8. So this is coordinate point u. U is now minus 2.8 and 1. Okay, minus 2.8 and 1. Okay, now let's move on to equation of u cube. All right, this is PT. For u cube, let's find the gradient. Now remember, it passes through q, it passes through u. So my gradient of u q, right? It passes through a. It passes through a and q. So let's do y2 minus y1, x2 minus x1. So this will be 2.5 divided by 3. If you're not sure, use your calculator, right? This is 0.5 minus minus 2 is plus 2, divide negative 3. It is negative 5 over 6. Now, since it has y-intercepts, q is a y-intercept. Your y-intercept is minus 2. So your equation is negative 5 over 6x minus 2. Okay. Now, what I need to do next is again find coordinate point T. Now, at point T, your y again is 1. So I put 1 inside, negative 5 over 6x minus 2. Bring over 5 over 6x is negative 3. X is 18 over 5. Okay, 18 divided by 5. Use your calculator. Yeah, 3.6. Right? Negative 3.6. Therefore, the coordinate of point U is negative 3.6 and 1. Sorry, this is not 0. This is 1. Okay, so you can see that VUT that lies on a straight line. It's a bit hard to see. It's a bit small. But let me draw it over here. Your V is most left is minus 4, 0. This is V. This is your U. Your U is 3.61. By the way, this is 1, not 0. And this is your T. Your T, I've got, sorry, I think I wrote this wrongly. This is not U, this is T, coordinate point T, 2.8. Negative 2.8 and 1. So in order to find the length of VU, this is U, this is T, VU, UT. Okay, my VU will be, let's take the bigger one minus the smaller one. The difference is 0.4. All right. Okay, then let's take your UT, take the bigger one, which is 2.8. This is 2.8 and 1. Negative 2.8. Smaller one, negative 3.6. The difference is 0.8. So we are supposed to find the distance of VUUT, which I got it here. All right, then I need to find the ratio VUUT. So VUUT is 0.4 to 0.8. The ratio is 1:2, right? Okay. All right. Now, next part. Let me move it down. Very hard to see. Okay. So Anas wants to hang the last part here. Let me do it over here. Anas wants to hang a picture frame at B in the diagram. He used a straight line PB to make measurement. Show that the string is not perpendicular to QU. Okay, he used straight line PB. Where's PB? Let me draw using this. This is PB. Okay, maybe use a darker line here. This one, thicker line, right? We need to find out whether PB, they say, show that the straight line is not perpendicular to QU. We already know QU, yeah? QU earlier has a gradient of this, negative 5/6. I need to find a straight line PB. Now, if you look at the diagram, where's your B? B is 1 unit to the left, and it sits on the x-axis. So it's negative 1, 0, right? So P we already have. So let me write here, Okay, let me find out the gradient. Gradient PB is y2 minus y1 minus minus 2, x2 minus x1. So this is 2 over 3. Yeah, gradient PB is 2 over 3. All right. Now, next, we take gradient of QU. We already have negative 5 over 6. Now, we need to show that they are not perpendicular. So gradient PB times gradient UQ or QU, doesn't matter, QU or UQ, we take 2 over 3 times negative 5 over 6. Now, if they are perpendicular, the gradient multiplied together must be negative 1. Now, in this case, we can cancel 2 and 6, that will be 3. This is negative 5 over 9. Now, notice it's not negative 1. If it's not negative 1, means what? They are not perpendicular, right? Not perpendicular. All right. Yeah. So before we go, just so you know that we have various type of books that is available on Shopee or our Lazada site, right? From Pusat Tuition Teliti, you can find us from there. That we have. There you go. This is me explaining about the books that we have, and we have past year question. What do you call that? A drill practice book, topical practice book. It should show you the Form 5 version with IGCSE A levels as well. And this is the Form 5 version, yeah, topical practice, past year question, our e-courses, which is complete tuition for a year together with the manual notes and tutorial books, right? And if you need a lot of additional practice, will be drill practice, will be a good book to have for practice. Yeah, you can find all this in our Shopee site or even our Lazada site. All right. So thank you so much for watching. Yeah, I hope to see you guys in the next video.